Read the question, no? Okay, you read the question. Meanwhile, I'll draw that. There's a rod, and this is the ring. There's a block B, block A, that one. A ring of, let's assume that some masses, M1, M2, length of the string, let it be L. There's a rod. Now I'm going to release it. So when I release it, let's first discuss the problem. It'll be easy for you. Then I'll come back to all the other things and all. So I'll ask you what is the displacement of block and the ring also. So the moment I release it, so the weight M2G will act. The weight of this M2G will act. And the string is just straight. So somewhere, and the moment I release, what happens? The weight will act, and because of it, it starts swinging. It starts moving. As it tries to move like this, length of the string will try to increase. So string will become taut. Tension will act. That tension, what it will do? Will act on the ring, and because of that, the ring will start moving towards right. So after some time, the position will be. And where is the block? The wedge block system. The block will be here. So let it make an angle theta. How the tension will act? Away from the body. And here the weight M2G. This much is what? The situation after some time. Okay, I want the displacement of block and the ring when string makes an angle theta. Can we calculate? Displacement of block. So initially this was the position of the ring, no? And finally, how much it is at a distance x. So can we calculate the displacement of the ring x minus x naught? So look at the net force acting on system. What are other contact forces? The normal contact N1 between the ring and the block. Net force on system along is 0. So therefore, still what you can write, the center of mass will not shift along y-axis. So xEMI equal to xEMF. Initial position of center of mass M1 x naught. I'm taking this as origin. You can take directly the ring itself as origin. It's left to you. If it is, this is the origin M1 0. Okay, so and let me choose. This is. Can we choose initial position of any object as origin? Yes. Then in that case, this will become displacement of ring. Okay, fine. You can choose wherever you want origin. I made this as origin to simplify the calculation. So initial position of the ring, let it be origin. So here release it from rest. It is. I'll come to the options later on. So now M1 0, at what distance the block M2 is there at a distance L from the ring initially. So M1 plus M2. Finally, M1 x1 plus M2 L cos theta. Try to see this. At what distance the M2 is from origin L. Finally, at what distance it will be? X1 plus L horizontal distance of the block from the origin. At what distance it will be? This is X1. So what is this distance? L cos theta. So what is the equation needed? We needed X1, no? The x1 is what? The unknown thing which is needed. So can I solve it? Yes, we do have m1 plus m2 in the new denominator cancels out. So what is the resultant equation will be m2 m2l minus m2l cos theta equal to m1 plus m2 into x1. This m2l cos theta, I'll bring it on this side. So what is x1 is equal to? No, x1 is equal to m2l 1 minus cos theta by m1 plus m2. What is this? Displacement of the ring. Similarly, can we calculate how much block has moved? Yes, we can calculate. Or directly you can use formula. It's left to you. What is the state of this block? It will be having a velocity. What is the state of this ring? It will have velocity. Can we calculate that speed? Can we calculate that particular speed? Yes, we can calculate that one. So can I, how to get that speed here? So finally, okay, we'll go for, finally, what happens when string becomes vertical? This is one instant it can happen like this, no? So here is there's a block M2, and here it will have, or let it be V1, V2, I'll write it V3, V4. How to get the speeds, all other things. This is about that center of mass we brought it. Now let's get into the speed. What is the net force on system along x-axis? Zero, no? So shall I say there's a one point which will not at all move? One point in the string will have only vertical motion. Is it justifying? So what is that point? Center of mass of system. There's a one point on the string. I'm going to draw a vertical line. Okay, that particular point is that okay? No. What is that star mark? What it is? Center of mass of system. Really, you should draw a diagram, huh? So that you'll understand things very easily. Look at that center of mass of system. It never moved, no? C, I'll call it. How it has moved? Only it has displayed along y-axis. So option A, one point in string will have only vertical motion, correct? No, R and B will have moment of the same magnitude. Let's how to calculate this masses here. So this is M1, this is, let's come for this one. So decrease in potential of block M2, M2 GL should be equal to M1 V3 square. Okay, I'll write V3 V4 here. Here I'll write V1. M1 V1 square by 2, M2 V2 square by 2. Two unknowns are there, no? Can you apply conservation of linear momentum as net force is 0? So M1 V1 minus M2 V2. When the string becomes vertical, the speeds of R and B will be inversely proportional to their masses. Yes, it should be, no? So option C also we can pick up. R and B will always have moment of the same magnitude. R and B will always have moment of same magnitude. Will I agree? No, only when become horizontal momentum, no, along x-axis. You see what is the momentum here? So here M1 V3 is not equal to M2 V4. Any reason? What is a V4? How it is V4? V4 is somewhere in the plane, no? All the time not possible. But when the string becomes vertical, its momentums will be equal. M2, here you take theta. M1 V3 minus M2 V4 cos theta. The part of some momentum will be there along y-axis also, no? So therefore we can't pick up this option. And when the string becomes vertical, the speeds of R and B will be inversely proportional. R will lose contact with the rod at some point. What is R? R means R will lose contact with the rod at some point. Not possible, no? So almost all ideas are included here. Conservation of mechanical energy, conservation of linear momentum, and center of mass. If there's a friction between the ring and the rod, will you make any changes to the problem? Nothing, no. But you can't apply my equal to XCMF. If there is a friction between the ring and the rod, XCMI is not equal to XCMF. Then we can't conserve the momentum because net action force is acting. Can we apply even conservation of mechanical energy? No, the friction does work. So be careful, anything can be asked. Okay, now another system, some curved one, we have brought it. Read the question. That's all, no. See, delta XCM, delta FX 0, so center of mass will not shift. That's all.